So we are trying to use cost-benefit analysis to assess, to evaluate a project. In doing so, we are actually kind of judgmental. So we need to use yardstick. In principle, we should choose those projects that gives us the highest level of social welfare. Okay, so Bergerson in 1938 actually proposed a concept called social welfare function. So this society's welfare is a function of individual person's utility or happiness or welfare of each individual. So person 1, person 2, person n. So if we have this social welfare function, then the criteria, the yardstick that we can use to judge a project is whether this project improve the society's welfare. So conceptually is simple now. However, despite of the straightforward, the intuition of the concept is actually not easy in practice. While the concept is still important and still referred to, it has not been used in this way because of these two problems. First, we cannot measure individuals' utilities, and it's actually difficult. At least we cannot measure these utilities in a way that allows interpersonal comparisons. Secondly, there exist disagreements over the forms of social welfare function. What kind of function we should have? Bergerson's social welfare function just says society's welfare is a function of individuals' welfare, but it does not say what exactly the functional form. Therefore, in practice, it's difficult to apply this social welfare function concept. Okay, what about let's do it this way. Let's say, okay, for each individual, let's calculate benefit and costs. Benefit for individual 1, cost of individual 1, benefit for individual 2, cost for individual 2, so on and so forth. So let's calculate each person's benefit, net benefit due to these projects, and weighted them, sum them up. Okay, so this is called a net social benefit function. It is formed by the weighted net benefits experienced by individuals or groups. So we certainly, if we have this net social benefit, we can just choose the projects that has positive net social benefit or give the highest level of net social benefit. So compared with the social welfare function, here it seems that we have more specific functional form. So it's net benefit for each individual, weight them, add them up. Okay, so you can see that the weight can play a role in the final figure for net social benefit. If A is equal to 1 for all individuals, then every individuals, they are equally important to the society. Okay. AI could be average income for the society divided by the individual I's income. So if individual I's income is bigger than than the average incomes, then weight is lower. It has a smaller weight. So the poorer a person is, the more important he or she is weighted in the social net benefit function. Let's quickly look at an example. Suppose we have two projects, A and B. Two persons, poor and rich. So for project A, cost paid by poor is 0, benefits is 150. For the rich, cost paid by the rich is 100, benefit is 0. And let's set the distributional weights to be 1, which means both the poor and the rich are equally important. Then add up 1 times 150 plus 1 times negative 100, we get 50. Similarly, for project B, in project B, the poor pays $80 and gains nothing. The rich pays nothing but benefits $160. Again, we can calculate the net social benefit $80. So now if we compare A and B, we're going to say that, okay, project B is better than A because it gives a higher level of net social benefit. And this is under the equal weight. Okay, both the poor and the rich are equally important to the society. Okay, let's change the distributional weights. Suppose poor carries a weight of 2, rich carries a weight of 1. Then now the calculation of the net social benefit for project A will be 200. In contrast, net social benefit for project B will be 0. So now we are going to say that project A is better than project B. So here, if we weight the poor, if we give the poor a higher weight, we arrived at different conclusions. So you can see that the importance of weight in the net social benefit function. Okay, main problems of this approach is gaining accurate measures of the benefits and costs of each individuals or groups are difficult, and there's an issue on what kind of weight we should use. So these problems are basically the same as for the Bergson's social welfare function. Right, okay, what about let's do it this way. Let's vote. So let's use a democratic approach to make the decisions. Okay, so when we want to rank now, we want to rank different projects. However, in doing so, well, certainly majority voting, democratic majority voting is one way to make decision. However, we can run into problems. So what we want our decision making to be logical. Okay, what do I mean? Say if I think A is better than B and B is better than C, then logically I will think A is better than C, and we call this ordering. This preference is rational. However, the economist Ken Arrow actually shows that when we are assessing, when we are ranking more than 3 items, something undesirable occurs, and this is called Arrow's general possibility theorem or impossibility theorem. Okay, let's look at. Okay, Arrow established that in ordering of 3 or more alternatives by 3 or more people whose individual orderings are complete. Complete means for any options is either A is better than B or B is better than A. So individuals can order the options, the alternatives. And transitive, which is logical. Transitive means that if A is better than B, B is better than C, then we should arrive at A is better than C. Using majority voting, the majority decision, the aggregate decisions might not be transitive, so it becomes illogical. This means that a decision-making system based on majority voting by people who are strictly logical might itself be illogical. So, Arrow actually concluded that even in a democracy, you will need a set of decision rules, perhaps CBA, that will ensure logical decision makings. He called it benevolent dictator. Let's look at an example of this. Okay, so we have 3 persons in a society, 1, 2, 3. We want to rank 3 options, A, B, C. Person 1 think A is better than B, and B is better than C, and he also think A is better than C. So person 1 is ordering is transitive or logical. Similarly for person B, person 2. Person 2 think B is better than C, C is better than A, and consequently B is better than A. For person 3, he thinks C is better than A is better than B, and in the end, indeed, consequently, he also thinks C is better than B. So both 3 persons' ordering or preferences are complete and transitive, logical. Okay, let's vote on these 3 options, A and B. So let's say A better than B. How many yes vote? A better than B. Person 1 will vote yes. Person 2, no. Person 3 will be yes. So these 2 votes, 1 no. So the society's decision will be yes. Yes, okay, indeed, A is better than B. What about B better than C? Okay, person 1 will vote yes. Person 2 will vote yes. Person 3 will vote no. So again, we have 2 yes, 1 no. So the society, by using the majority voting, will think yes. So it's a tip. So then let's look at A better than C. So if the society's preference, the society's ordering is logical, is transitive, since the society says A is better than B, B is better than C, we should expect A is better than C. Okay, let's vote whether A is better than C or not. For A is better than C, person 1 will say yes, 1 vote here. Person 2 says no. Person 3 says no. So we have 1 yes vote, 2 no vote. So the society, by majority voting, will say no. So now we have these situations. The society says that A is better than B, B is better than C, but A is not better than C. So now we end up in having this conflicting ordering. So the ordering, the society's ordering is not logical, not transitive. And this is something that we don't like. All right, so majority voting kind of fails here. So it leads to a return to a dictatorial approach based off the Pareto criteria. Okay, over time, a number of versions of this have been developed. So this criterion or these yardsticks are concerned with how to define efficiency, where an improvement in efficiency means, first, with given resources, has the project increased the volume of goods and services that people want or make them more in line with people's tastes? Or has the utility or happiness increased in the view of people themselves? Okay, so this Pareto criteria says that, okay, a project, a change, is Pareto improvement if these projects makes one or more persons better off without making anybody worse off. So somebody, due to this project, somebody is better off and nobody is worse off. Okay. So if a project results in somebody being better off and nobody being worse off, then we call this project is Pareto. Then we call this project achieves a Pareto improvement, and it's good. It's good because the society's welfare is increased. Somebody gets better off, nobody gets worse off. And if there's no such opportunities for Pareto improvements, then the society achieves a situation we called Pareto optimalities. Okay, there's no opportunity that for any project that can make somebody better off and nobody worse off. Okay, so that's one criteria we can use to judge. Okay, examples. For example, like a trade agreement, free trade agreement with two or more parties. That could be a Pareto improvement. Or a dam is built to generate electricity. Farmers in the valley are replaced and electricity prices are reduced because there are more supplies of electricity in the market. The gainers are the electricity users because now the electricity price drops. If the gainers can and do compensate the losers, which are the farmers down in the valley who are replaced, then we call this dam project achieve a Pareto improvement. Okay. In reality, is sometimes if we use this Pareto criteria or Pareto yardsticks, it could be too strict. For example, a project can end up in make somebody better off, at the same time make somebody worse off. Like the dam projects, the farmers are worse off. However, in that particular examples, they are compensated so that they are not worse off anymore. In practice, it might be difficult. This kind of compensation might be difficult to implement in realities. So if we use this Pareto criteria, Pareto yardsticks, we might end up in having no projects, or it might be too strict. Okay, so let's use another criterion, Kaldor-Hicks, or potential compensation test. So it says that a project is an improvement if the gainers from the change from the projects can overcompensate the losers, then they can overcompensate the losers from the change and be no worse off. They do not need to actually compensate. Okay, this says that as long as the total gains to the gainer is bigger than the total cost to the losers. Okay, so that the gainers can overcompensate, but do not necessarily do this. Continue with dam example. A dam is built to generate electricity. It results in farmers being worse off and electricity users being better off. So if total gains to electricity users is higher than the loss to the farmers, then by using this Cauchy-Hicks criterion, Cauchy-Hicks yardstick, we are going to say that this dam project is good. And in here, we only require that the electricity users can overcompensate the farmers, but do not actually compensate. Okay. And I hope you appreciate that later on, that when we are calculating the present value of net social benefit, we say that the present value of net social benefit associated with this project, this dam project, is $1 million, which is positive. We conclude that this project is efficient. In doing so, we are actually implicitly applying the Cauchy-Hicks compensation tests, the Cauchy-Hicks criteria. Okay, right. So let's add one more condition on this Cauchy-Hicks criteria. So then we get what is called Stokesky's reversal test. It says that a change, a project, a policy is an improvement if the gainers can overcompensate the losers, pass the Cauchy-Hicks test. In addition, the losers cannot bribe the gainers into not desiring the change. Okay, so this is one additional condition. So if a project passes these two criteria, we say that okay, it is good. It passed the Stokesky's reversal test. Okay, it's difficult to find examples. Right. One more criterion, Littl's criterion. So Little is more concerned with distribution of welfare, the distribution effect. Both the Pareto criteria or Cauchy-Hicks criteria or Stokesky test, they don't worry about the implication of distribution of wealth. So here it says that a change is an improvement if the Cauchy-Hicks criteria is met with the Stokesky's reversal test and the relative distribution of income is not worsened. So this project does not worsen the income distribution in the societies. So Little was concerned with the income distribution, the equity issues. However, the downside here is that by having two paths to his criterions, you might end up with situations in which there's no answers. For example, like this. We have 4 projects, A, B, C, D. Project A is efficient, passed the efficiency test, Cauchy-Hicks test. And it does not decrease the income distributions or does not worsen the inequality issues. So both efficiency and equity. So it's easy to make decision on project A. So it's a yes. Similarly, for D, it's not efficient, and it also worsens income distribution. So we are going to say this is no. However, for B and C, B is efficient and worsen the income distribution. There's equity issues, and C is not efficient. However, it improves the society's income distributions. It helps achieve equities in the society. So A and B, what's the final decision? We don't know. Okay, in practice, what we do is, it is general for economists to do this in CBA and maybe in elsewhere. First, assess the efficiency aspect of a project using Cauchy-Hicks compensation test, or calculate the present value of net social benefit and judge whether the NPV is positive or negative. Then draw attention to distributional consequences of the project. Maybe frequently for projects, some projects, it might have a small implications for the income distributions. For example, you want to build a bridge on the Ross rivers, that you might be able to ignore the distributional consequences. For other projects, for example, like a superannuation project, so the government may want to say raise the employer's contribution to superannuation from say 9% to 12%, and such a project will have a massive implications for income distributions in the societies. Okay, third, then allow politicians or decision makers to make any required trade-offs between efficiencies and equity distribution consequences. That's a general practice that we want to have for the cost-benefit analysis.